Hello viewers, welcome back to Smart Interviews, your one-stop solution to 𝗟𝗃𝗃 or tech interviews. Yet another contest, yet another solutions video. We are here with Codechef Starters 178, 𝗙𝗶𝗹𝗶𝗆 4 problems and their solutions. So let's get started without any further ado.
Alright, so let's get started with the first question. The first question being food balance. Chef is preparing to cook his dinner. There are two dishes chef can make. The first one contains F1 grams of fat and P1 grams of protein, while the second contains F2 grams of fat and P2 grams of protein. Chef would like to quantity Chef would like the quantity of fats and proteins he consumes to be as close to each other as possible. That is, the absolute difference between amount of fats and proteins should be as small as possible. Help chef by telling which dish he will choose or if both dishes have the same difference. So the input format, he gives us four integers. Yep, four integers. And the output has to be one of these three, that is first or second or both, without the quotes. That is first if chef will choose first, second if chef will choose second dish, both if both the dishes are equivalent. Now this is something you can ignore as well. It just says the case insensitivity. And coming to the constraints, pretty less, you need not worry about that. Sample one, the explanation, you can go through it. The question link will be provided in the description. You can go through it and you can follow the process for every question. That as soon as we start a question, you can go to the link, you can search the question, skim through the question, try to figure out the solution, try to type it out, and then later come back and refer to what we are going to discuss over here. So I would like you to pause, go to the question, try it out, and come back. All right, let's continue. So, pretty simple question. So, basically, we need to rely on the absolute difference between the first dish and the second dish. So, let's start with the input. We know the first line scan or scan equal to new scanner system in. Then int first one is f1, right? So int f1 equal to scan dot next int. And now instead of writing four times, I will tell you a shortcut. You need to use alt shift down arrow to replicate a line below, alt shift up arrow to replicate a line above. So we need four lines. I replicated all the four lines. Let me make this p1, and for the second two lines let me make it p2, f2 and p2. Now I know that the uh, absolute difference one is the absolute difference of P1 and F1. Likewise, I know that absolute difference of the second dish is math.abs of P2 and F2. Among these both, what do I need to choose? I need to choose if ABS1 is less than ABS2, I need to choose the first dish, because what did the chef want? Chef wanted the absolute difference between amount of fat and protein should be as small as possible. So if absolute 1 is smaller, then what do I print? I print first. Likewise, else if absolute 2 is smaller than absolute 1, then what does chef have? The second dish. So to replicate a line, we did alt shift down arrow. To move a line below and above, we need to use alt up arrow, alt down arrow. Second, otherwise, that is if absolute 1 is not less than absolute 2, if it is not greater than absolute 2, then it should be equal to absolute 2. And in such a case, I can simply print both. And as they mentioned, these are case insensitive, so you can print as you want it to be. Okay, for the first test case, it is as expected. Let's check for the second test case as well. Second test case as well is working, and we have one more test case, so let's try for it. First expected, so let's submit it. Correct answer. Let's move on to the next question. Now, coming on to the next question. The next question is placing 0, 1 and 1, 0. You have x01 strings, y10 strings. You will form a new string s by first rearranging these strings in some order and then concatenate them in this rearranged order. Let f of s denote the number of indices I such that 1 less than equal to I less than s mod s, that is length of the string, s of I not equal to s of I plus 1, that is the current character not same as the next character. You need to find the minimum possible value of f of s, that is number of indices such that the current character is not equal to the next character. You need to find a rearrangement of the given x01 strings, y10 strings such that minimum possible value of f of s is obtained. All right, cool. So pretty straightforward, but let's take an example and try to understand. So when I take an example, let's say xy values are 2 and 2 or 2 and 3. Now 2 and 3 means 0, 1, 0, 1, 1, 0, 1, 0. Okay, let's try to understand with one of the rearrangements. 0, 1, 0, 1, 1, 0, 1, 0, 1, 0. So how many adjacent pairs are possible? Firstly, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is, can I say that it is number of characters minus 1? Number of characters minus 1 is 2 into x characters are there, 2 into y characters are there, because for x there are 2 characters for each. For y type strings there are 2 characters for each. Minus 1. This is one thing that we have understood. That is the number of pairs. The number of pairs. Now coming to the number of valid pairs. First pair is valid. Second pair is valid. Third pair is valid. Fourth pair is invalid. And rest all the pairs are valid, making it 8. So in total, how many pairs were there? Total pairs were, let's write it here, total pairs 9. Among them, 1 is invalid, so 8 becomes one possible rearrangement's answer. Now we want this to be as minimum as possible. When do you think we'll get as minimum as possible? We understand one thing, that when I place these 1 0 adjacent to each other, all the 1 zeros adjacent to each other, every pair was valid. So is placing all these adjacent to each other would be a great option? No, right? We need to place it like alternating between them. We need to place it like alternating between them. So let's try what happens when I try to alternate. Now one way of alternating is 0 1, then 1 0, then 0 1, then 1 0. Then I am needing to put 1 0 at this point. Well, instead of putting it here, I can also put it in the front. Why should I put it in the front? To make it alternating in nature. Now what is the use of having it alternate? There is still this one pair that is formed, but the second pair is not formed. Third pair is formed, fourth pair is not formed. Fifth pair is formed, sixth pair is not formed. Seventh pair is formed, eighth pair is not formed. Ninth pair is formed. There is no tenth pair. So in total, what is the number of pairs? 5 valid pairs. So f of s values, these are nothing but, let me write this as total pairs. Then f of s values are these, and these are rearrangements you can assume. Try to take 2 to 3 more rearrangements and check which of these rearrangements is getting as minimum possible, as minimum value as possible. You will ultimately identify that alternating is the only way to get as minimum as possible. Well, this was possible because 2 3, so I could place these two pairs in between these three pairs, not pairs, strings you can say. But what if it is like, for a change, 5 3, that is 5 0 ones and 3 1 zeros. If this is the case, then what will happen? If this is the case, still I need to try alternating. Now for these three pairs, sorry, for these three strings, how many strings do I need to make it alternative in nature? Plus one of this would make it alternative in nature, that is plus one of 0 1 type strings. For 3 1 0 type strings, plus one of that, that is 4 0 1 strings would make it alternative in nature. It can also be two, it can also be two. So it is something like either x should be y minus 1 or y plus 1 to make it alternative in nature. But then what about the extra strings? What about this extra 0 1? Let's make it like 6, maybe that will give us a bit more clarity. What about this surplus 2 0 1s? Can you do anything about it? No. For these I understood that yes, we can do something about it. We can alternate these up and we can get as minimum pairs as possible. But for the surplus pairs, can anything be done? No, right? We cannot do anything. So we will leave these surplus pairs as it is and we'll try to get an alternating string. So if I leave these surplus pairs 0 1 0 1, I left it. Alternating pairs, I can get 0 1 here, then 1 0 here, then 0 1, then 1 0, then 0 1, then 1 0. With this, 3 1 zeros are done, and finally one more 0 1. So 4 plus 3 7 alternating pairs, and two pairs that cannot be alternated. So in total 9 pairs we have found in this rearrangement. What is the f of s value? 1 2 3 4 5. Then sixth is not valid, seventh is valid, eighth is not valid, ninth is valid, 10th is not valid, 11th is valid, 13th will be valid, 15th will be valid, 17th will be valid. So in total, how many am I getting? 1 2 3 4 5 6 7 8 9 10 11. 11. Try any other rearrangements for 6 3 and see if you can get anything lesser than 11 possible. Now if I am able to generate this, then counting isn't something difficult at all, because at every index I need to check the next index element, that is it. If both are different, I will do c++. If both are same, I will not do c++. That's nothing more than that. So I will do count plus plus. If both are not same, that is if s of I is not equal to s of I plus 1, I will do count plus plus. Otherwise I will not care about it. Otherwise I will not care about it. So let's try to convert the same logic to code. What is our logic? Our logic is, among these two x and y, we firstly need to know the minimum. Why do we need to know the minimum? If I know the minimum, the plus one or the plus one of that you take from the maximum of x and y, then you can form those many alternating pairs. How many can you form? You can form minimum of x comma y plus 1 alternating pairs. You can form minimum of x comma y plus 1 alternating pairs. And apart from this, whatever are these surplus pairs, we are going to leave them. So this will be our alternating count. Our alternating count. For these many times, I can pick whatever is the maximum of x and y. If let's say here x is maximum, right? So I can pick 0 1, then 1 0, that is 0 1, then 1 0, then 0 1, then 1 0, then 0 1, then 1 0, then 0 1. And with this I have found the alternating string, and apart from this, whatever are remaining, those I will append or prepend to this string. Now that is going to be fine. That is going to be fine anyways, because no matter you put 0 1 0 1 here or 0 1 0 1 here, the same number of pairs will get added up. You can verify this. That is putting 𝗏𝗏 over here or putting 𝗏𝗏 over here. Either of these will give you same amount of pairs, same amount of additional pairs. So for the alternating count times, I need to append into a new string. Let's try to convert this to code. Alright, let's get started with the code. I need to take the scanner first. Scan equal to new scanner system in. Then int t equal to scan dot next int. Then while t minus minus int x equal to scan dot next int. Then int y equal to scan dot next int. You can use that shortcut and do it here. I'm just writing it as it won't take much time. Now among these I can get the alt count math.min of x comma y, math.min of x comma y. Now for these alt count times, it is not even x comma y plus 1, and I need to know which of these is maximum, right? I need to know which of these is maximum. So x01 strings, y10 strings. Yeah. So I really do not care about 0, 1 and 10. I can have the inverse of it, that is x10 strings and y01 strings as well. It will be exactly the same. It will be exactly the same. So all I need to worry about it is what is maximum. Now apart from alternating count, there is surplus count of math.max of x comma y. Now from math.max of x comma y, if I take out the alternating count, then I'm going to get whatever is the surplus number of strings I have. I'll get the surplus number of strings I have. So for int I equal to 0, I less than alt count I plus plus. Let's also take a temporary string. Let's take it as s itself, empty. For alt count number of times, what do? I add 1001. I add 1001. You can do it 0110 as well, not an issue, because this is nothing but an alternating pair, whatever I mean. And this is for alt count times, which means math.min of x comma y plus 1 times. Well, this plus 1 has to be whatever the last character, last 01 or 10, right? So let's not include it here, or maybe we can exclude it here using this. And finally I can do simply 10, sorry, 01 01, because here I'm taking 01 as the start, right? So 01 has to be appended at last as well. That is what we exactly did over here. If you see that is what we exactly did over here. So what is the alt count in here? Alt count for this case comes out to be 3 plus 1 4. 3 plus 1 4. So 4 times this 0110 0110 0110. This, is it happening for 4 times or 3 times? 3 times, along with one extra x string or y string. Doesn't really matter, because ultimately we know that either of them will give us the same output. So 3 times I'm appending 0110, and finally I'm appending 01. Is the same happening over here? Check. Exact same is happening over here. Alt count minus 1 times, you're appending 0110, then you're appending 01 at last. So with this, the alternating string is formed. Now for the surplus number of times, let's also verify surplus count. So when I'm talking about surplus count over here, surplus count is math dot max of 63, that is 6, minus alternating, which is 4, that is nothing but 2. It is nothing but 2 pairs, right? So are our formulas correct? Yes, surplus count and alt count formulas are working completely fine. Alt count is 4, surplus count is 2, and based on that we are forming the string. So for int equal to 0 I less than surplus count I plus plus. And for surplus count number of times, what do I add? What did I add over here? I added 0, 1. I added 0, 1. So I am going to do the same thing. I'll add 0, 1 over here. With this, I have formed my optimal string. Why am I calling it optimal? Because that will only yield me my minimum possible value. That will only yield me my minimum possible value. Now I need to find out f of s. So let's take int c for that. For int equal to, I need to check the current character and next character. So I can start from the 0th character. I need to end at n minus 1th character. Here n should be the size of the string, right? So let's take it as s dot length. In Java, length is a function for strings. For array, it is parameter, not a parameter, field you can say. So if, okay, just a minute. Yeah, if s dot char of I equal to s dot char of I plus 1, then c plus plus. And finally, I need to print the count of this. Again, why are we taking optimal string? Because for the optimal string, that is for the alternating fashion, I identified that, okay, we missed semicolons here. I identified that for the alternating pattern only, I'm going to get the minimum possible value of f of s. So I'm trying to replicate the same thing in code. Forgot alt count here. Okay. Wait. Is it as expected? Where is it going wrong? Think for a moment. Pause the screen here. Think for a moment. Right. So we missed out this, and let's try to run it. Okay, all the cases are right except for the second case. And what is second case? 1 1. Let's try to trace what is happening in our code for this 1 1 case. Now for this 1 1 case, what happened? Alt count came out to be 1 plus 1, that is 2. Surplus count came out to be max of 1 comma 1 is 1, minus 2 is minus 1. That is, this loop is running for minus 1 times. And secondly, this first loop is running for alt count minus 1 times, that is 0 1 1 0 gets appended once. And after that, I am doing this by default. So should I be doing it by default? Because of this append at last, what happened? My string became 0 1 1 0 0. And here what is the answer? 0 1 is one pair, 1 0 is one pair, 0 1 is one pair. But then actually I can have only two pairs over here. So ultimately, where am I going wrong? I'm going wrong with this statement. So when should I do this statement? When should I perform this? Only when x is not equal to y. Only when x is not equal to y, we can get that surplus. Now anyways, what is surplus count here when 1 is the xy? Surplus count came out to be minus 1, right? So when surplus count came out to be minus 1, the second loop is anyways not going to run for any number of times, because I is starting at 0 and I is by default greater than minus 1. So second loop will not run. And at this point, to not bring it till 0 1 and to stop it at 0 1 1 0, you need to be modifying the code like this by appending 0 1 only if x and y are not equal. So let's try this. 32, 39, 9. All right. So this was kind of a linear approach where I'm creating the string and then I'm validating the count or counting the number of valid pairs. So instead of this, while explaining itself, you would have understood that there can be a formulaic approach that can be used. So based on the counts, based on the number of times we are having this alternating string, you can get a final count, final answer directly. Try to come up with that. That is a minor optimization on top of this. So here for 10 power 4 cases, I'm running for these many number of times, right? So simply I'm creating x and y, 0 1 1 0. So it is 2 into x plus y. 2 into x plus y in the worst case can be 200. So 200 into 10 power 4 is the current number of iterations. If you do not want to create this string, then you can directly find out the count using formulaic approach. Try to come up with that. That will take only 10 power 4 iterations, because for every test case you can directly using a formula get the answer value. You can directly get the answer value. All right, cool. So this was about the second question. Moving on to the third one. Third question is permutation construct. A permutation of length n is an array of length n that contains every integer from 1 to n exactly once. Given n and k, find a permutation p of length n satisfying the following constraints. Constraints are p of I not equal to I for all numbers 1 to n, and p of I mod k equal to I mod k for all numbers 1 to n again. In case no such permutation exists, output -1 instead. Input format is you're given t-test cases in which each case has n and k values, and output format is if a valid permutation exists, you will be printing the permutation, otherwise you'll be printing -1. If there are multiple permutations, you may print any of them. So this is one more thing that you need to be observed. Now coming to constraints, well, nothing as much we have to care about. A very brute force approach might also seem to be working. Well, here there is a twist. What is a very brute force approach for permutation constructing? I need to generate each and every permutation, which is usually done using backtracking and which demands more time even for less amount of numbers. So here there should be something other than generating every permutation and testing. Generating every permutation and testing, obviously that can be our brute force approach, which will take 2 power n time. 2 power n time here is 100. So is there any other way to do this? Well, there is a hint given to us using the constraints. Can we perform anything using these constraints? That is what we need to think about now. So let's take a quick example and try to perform this. The case given to us is 4 2, right? So let's take n equal to 4, k equal to 2. N equal to 4, k equal to 2. Now for 4 2, I need to get a permutation of 1 2 3 4 such that I not equal to pi, permutation of I, and pi mod k is nothing but simply this, is equal to I mod k, is equal to I mod k. I know one thing for sure, that any x mod k belongs to 0 to k minus 1, belongs to 0 to k minus 1. That is, when I take k equal to 2, when I take k equal to 2, 1 mod 2 is 1, 2 mod 2 is 0, 3 mod 2 is 1, 4 mod 2 is 0. This is mod 2 values. This is mod 2 values. Now, what do I understand by this? What do I really understand by this? Nothing much, right? Well, firstly, if you consider this permutation, it is disobeying the first condition, that I not equal to p of I. Because if you see here, whatever the indexing he has given in our question is 1 based indexing. So 1 equal to 1, 2 equal to 2, 3 equal to 3, 4 equal to 4. Well, I see that the modulus values of 2 and 4 with k are same. Likewise, 1 and 3 are same with k. Let me highlight it in some other color. 1 and 3 are same with k, which means can I perform a swap operation on these? Yes, I can perform a swap operation on this, and by performing swap operation, what do I get? 3, 4, 1, 2. Does this obey the first condition? Absolutely yes. Does this obey the second condition? Still absolutely yes, because still the modulus to count is uh, 1 here, 0 here, 1 here, 0 here. And if you take the indices, we need to consider the indices, right? So 1, 2, 3, 4. If you take modulus values here for indices, you'll get it as exactly the same. You'll get it as exactly the same. So what do I understand with this? Well, this was k equal to 2. Maybe we found it out very easily. Let's try for a different case, like just a minute. Let's try a different case like n equal to 6 or n equal to 7 and k equal to 3. Let's see what will happen over here. Now n equal to 7, I know that default permutation is 1, 2, 3, 4, 5, 6, 7. Obviously, the first condition itself is not applicable. The first condition itself is not applicable. The second condition we need not worry about it as of now, because this is invalid in total, because first condition itself is not applicable. Now coming to the modulus values, I'm taking modulus with 3. That is 1, 2, 3. Then 4 is 1, 5 is 2, 6 is 3. 7 is 1. Just think about the second condition, like will it be the same? Yes, right, the indices and the values are same. So second condition is applicable, but still first condition is not applicable. Now what can I do about the first condition? Well, I see one thing, that there are three numbers having the remainder same, which means can I place the 7 in fourth index or even in first index? I can place it because 7 is not equal to 1 or 4, and 7 mod k, that is 7 mod 3, is equal to 1 mod 3 and also 4 mod 3. So what do I understand by this? Numbers having the same remainder can be placed in multiple slots or can be interchanged. The slots, their slots can be interchanged, that is the indices can be interchanged. So ultimately what I simply will try to do is I'll put 1 in 4th slot, I'll put 4 in 7th slot, and I'll put 7 in 1st slot. This is absolutely valid for 1. Now let's think about 2. For 2, there are 2 spots, that is, there are 2 spots with remainder 2, hence I can simply swap these numbers. For 3, there are again 2 spots, I can simply swap these numbers. And did I get my valid permutation? Absolutely yes. So try to do this for a few more cases, and this definitely will work. Now coming to invalid cases. Well, let's see what invalid cases he has given here. The invalid cases that he has given here: n equal to 4, k equal to 3. n equal to 4, k equal to 3. Now when I take n equal to 4, k equal to 3, firstly as usual, I can take the default permutation 1, 2, 3, 4. Then k equal to 3, as in the remainders are going to be 1, 2, 3, 1. Now there are two elements having remainder as 1, and their slot numbers are also having the remainder as 1. Now ultimately I can swap these and ensure something different from it happens, and the first condition will validate. Now what about 2 and 3? 2 and 3, do they have any other slots to go? Are there any other slots having 2 as remainder or 3 as remainder? No, right? So ultimately what do we understand? Well, if there is at least one more slot for the current number to move, then I can definitely accommodate it over there. And whatever that one more slot number was there, no? One more slot number was there. No? If 2 moves to that slot number moves to 2's slot. So something like this will happen. If multiple are there, then you can rearrange them as much as you want. It is up to you. It is up to you. That is 7 need not be placed only at 1. It can also be placed at 4, I mentioned, right? Similar thing. So ultimately, what do I need to know? I need to know for every remainder with k, that is 0 1 2 k minus k minus 1, not k minus 1. I need to know how many numbers are going to come over there. If I know the numbers that are going to come over there, not just the count is sufficient, we need to generate the permutation, right? So we need to know what are the numbers coming over. Now in this case, 0 remainder, there are three numbers: 1, 4, 7. 1 remainder, how many numbers? Sorry, not 0 remainder, my bad. Oh, sorry. This is 0 remainder, guys. My bad. 0 remainder, two numbers, 6 and 3. 6 and 3. Then 1 remainder, three numbers, 1, 4, 7. Then 2 remainder, two numbers, 2 and 5. And that's it. I know that for 0 there are two numbers coming. For 1 there are three numbers coming. For 2 there are two numbers coming. I can simply switch their places. I can simply switch their places. I can simply switch their places. And my simplest way of switching is moving every element to its next position in a cyclic manner. That is, the last element comes to the first position at last. So let's try to implement the same in code. And when am I identifying as invalid? When the numbers are having only single slot. Here as well, it is 0, my bad. Only single slot. Only single slot. Okay, let's get back to writing the code. Again, I need to start with scanner. Then entity equal to scan extent while t minus minus greater than 0. Then int n equal to scan dot next int. Likewise, I know how to get it in the second line using alt shift down arrow. Okay. Now, after getting an nk, what was my task? I need to know for every number, sorry, for every remainder, how many numbers are possible? What are all those numbers possible? So I need to maintain something along with that other thing, which for which we usually use hash map. Something that is the key along with the other thing that is the value. Here the key is integer, the value is an array list of integer you can take, because we do not ideally know how many integers are going to come. So integer array list of integer hm equal to new hash map. Now you can also identify that we are using the remainders as 0, 1, 2, which are nothing but ideally the indices of an array. So you can use an array of array lists as well, that also works fine. Array of array lists or array list of array lists, also those work fine. But I am sticking to hash map. So what will I do in the hash map? For every element I need to traverse from 1 to n inclusive. So after traversing, I need to know what is the remainder. The remainder is, let's store it. I need to use at multiple places. Remainder is I percentile k. If remainder is already in the map, that is, if hm dot contains key, if it contains the key, then all I need to do is I need to get the array list at that point, and I need to push, that is, add to the array list the current element. The current element is I. Else, that is, it does not have the key, which means I am going to create a new entry, that is for which we use hm.put remainder, and you're going to create a new array list. And after creating a new array list, this is generic type, we need an integer array list, and we are going to insert hm.get of remainder dot add of I. Now you see that hm.get of remainder add is similar in both. So I can just move it out of the block and I can have it as a single block, for which I check for if the hm does not contain the key. So if hm does not contain the key, then I'm going to make it a new entry with a new array list, and then I'm going to add. If it is already containing the key, then this if block will not execute, you will directly add in the map. Now with this loop, I'm going to get all the remainders along with the along with the elements in each of those slots, in each of those remainder slots. Now I need to check at any point if I'm getting uh, 0 or 1, sorry, not 0, 0 is not possible. If I'm getting one element in a particular remainder slot. So firstly, to iterate through the hash map, you use key set hm dot key set hm dot key set. Let's take it as remainder in the key set. I can get the array list of integer, let's say ar equal to or elements equal to hm dot get of remainder. Now if elements dot size equal to 1, then obviously I need to print a minus 1. So for that, let's keep a track of using a flag variable, flag equal to false, because I need to know if I'm stopping because of invalid case or because of successful generation, right? So here I will turn the flag as true, that is I am unable to generate a valid permutation, or let's write vice versa of it, makes more sense, and we'll break it from there. Otherwise we saw that I'm going to cyclically put it uh, cyclically put the elements in the next slots, right? So for int I equal to or here as well, are well actually I need a for loop. Okay, fine. For int I equal to 0, I less than n, here it is not going to be n, here it is elements dot size I plus plus, elements dot size I plus plus. Now since we are breaking in the if block, I need not have the else, I can directly have it here, because if the if block did not execute, I'll directly execute after if the if block. If the if block executed, then I'll break it from there. So I need not worry about executing this after. Alright, coming to cyclically putting it in the slots. Well, I need a permutation array which was not taken as of now. Permutation array, new int. What should be the size? N size, right? N size. But if you see one, this is a one based index. So let's take n plus one size, n plus one size, and let's take it as p. So for every element, I'm going to put it in the next element place. For every element, I'm going to put it in the next element place. That is, uh, here 1 is going to be put in 4th place. Then 4 is going to be put in 7th place. Then 7 is going to be put in 1st place. So next LA is equal to elements dot get of I plus 1. But then this I plus 1 cannot be applicable at the last index, so let's keep it as I minus 1. Now whatever is the next element at that position, I'm going to put the current element, which is elements dot get of I, elements dot get of I. And finally, where will the last element go into? At the first element position. So elements dot get of 0 equal to whatever is the last element, that is elements dot get of uh, elements dot size minus 1. And with this my permutation is filled. My permutation is filled. For every remainder this has to be done. For every remainder, once I do it, my permutation will be filled. And where is my answer finally? My answer is, firstly I need to check the flag. If the flag is false, that is if not of flag executes, then I need to print minus 1. Otherwise I'm going to print the permutation. My permutation is starting at 1 index, if you remember right. And to make this happen only, we took the permutation array sizes n plus 1. So system out println, not println, print elements dot, sorry, p of i, p of i plus space. And once all the elements are printed, a line at last. More or less that's it, I guess. Let's see if it works, or did we miss something? 3412 231. Well, we got 312. Think if it is in the right position. Three remainders, three remainders. Okay, 3 and 1, right? So n is 3, k is 1. uh, 3 remainders 0, 1 remainder is 0, 2 remainder is 0, 1 remainder is 0. 2 remainder is 0, sorry, 3 remainder is 0, 1 remainder is 0. It seems to be confusing, I guess. So initially our array was n equal to 3, k equal to 1, which means our array was 1 2 3, and the indices were also 1 2 3. If I take mod 1, I'm going to get 0 0 0. So what can I do? 1 in 2's position, 2 in 3's position, 3 in 1's position. That is what we did here, 3 1 2. But what did he do? 2 in 1's position, 3 in 1's position, sorry, 3 in 2's position, and 1 in the last position. Both of them work fine, because ultimately we can see that the remainders for all these three values are 0. And let's submit. Let's see if this works. All right, that's it for the last question. Sorry, that's it for the last but one question. And now finally coming to the last question. The last question is smoothly increasing an array of an array b of length m is said to be smoothly increasing if it satisfies either of the following conditions: m equal to 1 or b1 less than b2 less than bm. That is, all these elements are increasing, that is strictly increasing, they are not in non-decreasing fashion, and the difference array b2 minus b1, b3 minus b2, so on, bm minus bm minus 1 is also smoothly increasing. Now we need to understand what does this smoothly increasing mean, and for that he is given, that is, an array is smoothly increasing if it either has length 1 or it is strictly increasing and its difference array is smoothly increasing. Now if you see this, has length 1 was nothing but the first point, and it is strictly increasing is this part, and its difference array is smoothly increasing is this part. That is, whatever he has given here in words is nothing but whatever he explained here in expressions. And he also told a point that note that this definition is recursive. That is, for an array to be smoothly increasing, all of its difference arrays should be smoothly increasing. We'll try to understand this with example. You can also navigate to the question. You can check out the explanations here. I will additionally provide explanation. And apart from that, there is nothing but that nothing much that we need to know. So let's just look at this example for better understanding. Leave these valid cases. These invalid cases, if you see, 5, 3 is not increasing firstly. 10, 20, 30 is increasing. It is even strictly increasing. But if you take the difference array, that is 20 minus 10 is 10. Then 30 minus 20 is 10. Difference array comes out to be 10 and 10. 10 and 10, is it increasing? No. They are in non-increasing fashion, non-decreasing fashion. So 10, 20, 30 is also invalid, is also not smoothly increasing. So you are given an array A of length n for each index I. Answer the following question independently. Delete the element A of I from A without changing the order of remaining elements. Is the resulting array smoothly increasing? Now, if the deletion still kept it as a smoothly increasing array, then the binary string should contain a 1 at that position. Otherwise, it should contain a 0 at that position. That is at the ith character. So you need to output a binary string. Question seems to be confusing at first, but let's try to get a clear look at what he's trying to say. So if I take the first test case, if I try to take the first test case, or better than the first test case, I'll explain you the third test case. First test case explanation is given here itself in the question. Now moving on to the third test case, just a minute. Yeah, what is the third test case? N equal to 5, and the elements are, the arrays 11, 12, 13, then 20, 50. So firstly, let's try removing 11. If I try removing 11, what is the difference array? Difference array is 1, then 20 minus 13 is 7, then 50 minus 20 is 30. That is, the difference array is 1, 7, 30, which is strictly increasing. And at the same time, is it smoothly increasing? To know if it is smoothly increasing, again you need to take the difference array here. So if I take the difference array here, I'm going to get 6 followed by 30 minus 7 is 23. This is also strictly increasing, and I need to check if it is smoothly increasing, if its difference array is smoothly increasing. Difference array, again you are going to take the difference here, which we will get it as, let me write it in a different color, 17. And 17 is a single element. If you remember, if m is equal to 1, he told that it is a smoothly increasing array. So here it is smoothly increasing. 6 and 23 was smoothly increasing, 1 and 7 was smoothly increasing. Hence, deletion of 11 kept the array as smoothly increasing. So we'll mark it as 1. Kept the difference array as smoothly increasing. Uh, yes, kept the array as strictly increasing, and the difference array is smoothly increasing. Difference array also, you need to break it. This is what he mentioned by recursive in nature. Definition is recursive in nature. Now coming to the next element removal. If I remove the next element, it is 12. So what is the first element? 2. Second element 7. Third element is 30. Again, if you see, this is a strictly increasing array. 11, 13, 20, 50 was also strictly increasing. 2, 7, 30 is also strictly increasing. Now to check if it is difference array is smoothly increasing, take the differences. 5, 23. Strictly increasing. Difference array is it smoothly increasing. Take the difference, you will get 18. And it is single element. So again, even after removing 12, what can I say? The array remains strictly increasing and the difference array remains smoothly increasing. So put it as 1. Likewise, if you check for 13, if you check by removing 13, you'll get the same, and that is the reason you are going to get 1 over here, as you can see, 1 over here. And now coming to 20, if I remove 20, what will happen? Let's see. If I remove 20, the series is 11, 12, 13, 50, which is strictly increasing. Now coming to is the difference are smoothly increasing. Firstly, we'll take the difference. If I take the difference, what will happen? 1, 1, whatsoever it is. You can leave this as why? Because 1 and 1 itself is not strictly increasing. Hence, is the difference are smoothly increasing? No. So here you will put it as 0. And what was the last test case? Sorry, last element removal, which is 50, 11, 12, 13, 20. strictly increasing array. Now coming to difference array smoothly increasing 1 1. Do we need to care about this? Not at all, because the difference array here itself is not strictly increasing. So again, for 50's removal as well, the array is not going to be strictly increasing along with its difference array smoothly increasing. So this is how we are going to get the answer as 111 followed by two zeros. 111 followed by two zeros. So I hope you understood that we are required to do something over and over again, which can either be done by loops, and here, as he mentioned that the definition of smoothly increasing is recursive in nature, you can do it along with recursion as well. You can do it along with recursion as well. Now, if I try to simulate this, what do you think will be the time complexity? For every element I need to remove it, I need to get a new array, I need to perform this checking if the array is smoothly increasing, difference array is smoothly increasing, which takes how much time? Initially I had four elements, then it became three, then it became two, then it became one, then it became one. That is how much time is it going to take? Initially, I had four elements, it became three, then it became two, then it became one. For each of these elements, I need to perform this checking operation, which is this is nothing but first in natural numbers. So number of iterations to check this is, if I take this as n minus one, you are going to get it as n minus one into n minus n into n minus one by two. This will be the number of subarrays I get while doing a smoothly increasing check. And like that, I'm going to do this for n times. I'm going to do this for n times. Now, I'll give you one of the ways, one of the thought processes. You can think of other thought processes. What thought process I'm going to give you is, here you can see that this is an n-cube approach. Obviously, for the given constraints, those are very, very high. That is, n is up till 2 into 10 power 5, very, very high. And do we need to worry about array of n? Not really. But do we need to worry about test cases? Yes, 2 into 10 power 4. But then he also told that sum of n across all the test cases won't exceed 2 into 10 power 5. That is, if there is one test case of size 2 into 10 power 5, then only that test case will be there. There will not be any other cases, because as I mentioned, sum of n across all tests will not exceed 2 into 10 power 5. Will not exceed 2 into 10 power 5. So this is what he means. One array with 2 into 10 power 5 size is the worst case. If I take this, will our approach work? Absolutely not. Well, think of this. Let's say I give you an array like 1, 2, 3, 4, 5. Does this seem to be increasing? Yes. But does its difference array seem to be smoothly increasing? Not at all. So obviously, for n equal to 5, can the max element be 5? No, it cannot be 5. Then if my n's max value is 2 into 10 power 5, do you think the maximum element will be 2 into 10 power 5? That is, there are going to be many elements. And do you think the maximum element will be 2 into 10 power 5? Not possible, right? For a very minimal value as 5 itself, it got failed. So for 2 into 10 power 5 as well, I'll still get the difference area as 1, 1, 1, 1, 1, so on, which is still not smoothly increasing. So then what is going to be the max element that we are going to have? So to understand this, let's reverse engineer. Now we understood that any array we take, we are ending up at one element. This is something that is inevitable, because in the smoothly increasing definition, he has given that when m is equal to 1, the array is smoothly increasing. So what do you think will be the minimum possible element that I can have in my array? If you check the constraints, the minimum possible element I can have in my array is 1. Let's say 1 is the last element I come across. Why do I need to keep 1 as the last element I come across? Let's say I start at 1, I keep going, I keep increasing my values until I reach x. And I start at 8, I keep increasing my values until I reach x. X is some high value, I do not worry about it as of now. Now, this x, I am assuming it as the last of the series, where the series length is 2 into 10 power 5. Obviously, it is not going to have 1, 2, 3, 4, 5 because we understood that 1, 2, 3, 4, 5 is not a smoothly increasing array. Its difference array is not smoothly increasing. So 1 to x, do you think more number of elements will be there, or 8 to x more number of elements will be there? Obviously 1 is lesser than 8, which means 1 to x, if there are some x1 elements, and 8 to x there are some x2 elements, obviously x1 is going to be greater than x2. Now what is the use of this? Well, this will help us reverse engineer our array elements. Let's start at 1 as the difference array element. Now 1 can be gotten using 1 and 2. Again, we are going to try keeping 1 as the minimum element because we ultimately understood this fact. So 1, I can also have 2, 3 here or 3, 4 here, but ultimately as per this fact, I'm going to keep it as 1 and 2. Now 1 and 2 difference array, what do you think the array elements must have been to get this? 1 and 2, I can get it using 1, 2 to get 1. Then 2, I need to have 4 to get 2. Yes, right? Because only 4 minus 2 is going to be 2. Now this array, whatever we are having in hand, can I say that this is strictly increasing? Yes. What about the difference array? The difference array is 1 and 2. What about this array? Is it strictly increasing? Yes. What about the difference array of this? 1. Is it valid? Is it smoothly increasing? Yes. Because these are nothing but these first few arrays I got, right? I assumed that this one is by default valid. And based on this one, I got 1, 2 as the two elements. Now based on 1, 2, I'm getting 1, 2, 4 as the three elements. Now based on 1, 2, 4, what do you think will be the elements? Try to pause the video here, try to expand it and resume and check. So if I continue further, if I keep 1 as the minimum element, to get 1 difference, I need to have the next element as 2. To get 2 difference, I need to have the next element as 4. To get 4 difference, I need to have the next element as 8. And if I continue further, 1, 2, 4, 8, 16. 1, 2, 4, 8, 16, 32. And this will keep going on. This will keep going on until I reach what is the maximum value of a of I? Maximum value of a of I is 10 power 9. A of I lies between 1 to 10 power 9. So 10 power 9. If you observe, these are nothing but powers of 2. These are nothing but powers of 2. That means if I keep increasing, the max element will come out to be some 2 power x value. Some 2 power x value. Let's not keep it as x. Some 2 power k value. Some 2 power k value. Now this 2 power k value, I know that maximum it can be is 10 power 9. So if I take 2 power k as 10 power 9, what do I get k as? I'll get k as log of 10 power 9 base 2. This will approximately come out to be 30. Approximately come out to be 30. What do I understand by this 30? If you see, if I have elements more than 30, I definitely know that for 30 elements, 10 power 9 can be the maximum element. 10 power 9 should be the maximum element so that I can have a smoothly increasing array. If I have even one extra element, it has to be greater than 10 power 9 to make it firstly strictly increasing. To have it smoothly increasing, it has to be some other number. Let's not worry about that number. It has to be some other number that is greater than 10 power 9. But we know that 10 power 9 is the maximum array element I can have, right? If I can have maximum array element as 10 power 9, then I definitely need to have only less than equal to 30 elements to have that array as smoothly increasing. I definitely need to have it as 30 elements to have that array as smoothly increasing. So if I'm having at least even one more element greater than 30 elements, then it definitely will not be smoothly increasing. And we are damn sure about it because we have done all this calculation to understand the fact that I need only 30 elements. I need only 30 elements. Any number of elements greater than 30 elements will definitely be invalid. Will definitely be, any array having greater than 30 elements will definitely be invalid. So now if I try to put 30 in this formula, what will I get? 30 into 30 into 30, 29. I'm approximating that to 30 by 2. So this is like 9 into 10 cube by 2, which is 4500, which is very less number of iterations. And if there are more than 30 elements, what can we do? We can simply skip that off. So let's try to convert the same thing to code. Obviously, we are not going to generate all this series and all. This was to understand that any elements more than 30 elements will not work. Will definitely not work, because if I'm having more than 30 elements, then I need to have something more than 10 power 9 as the max value to have a smoothly increasing array. Coming to the code part. So again, initially it is going to be the same scanner scan equal to new scanner system in. Then I'm getting int t equal to scan dot instant while t minus minus greater than 0. I need to get int n equal to scan dot next int, then int array equal to new int of n, and for int I equal to 0, I less than n, I plus plus array of I equal to scan dot next int. With this, my array is also scanned. Now let's forget about that 30 elements thing, and let's just see how I should be evaluating the given array. So for evaluating the given array, I need to remove each element from the 0th element to the last element once. So let's take that in one loop, what element to be removed. Now I need to form a new array. Let's not take it as new array, something like br array. Br array, if I remove one element from n elements, then I'll have n minus 1 elements. Now I need to fill in this br array from the 0th index, and that should be independent. So k equal to 0, int j equal to 0, j less than n, j plus plus. If my current element is equal to the deleted element, then I need not fill it in my br array. Otherwise I'll fill it in my br array. So br of k plus plus equal to array of I. Is it I or j? J, array of j, because j is what is going to create the new array, right? So array of j. Now once I have this array of j, I need to check if this array is valid or not. Now to check if it is valid, I need to do smooth check, something similar to smooth check. Smooth check is going to check my array if it is strictly increasing, and if its difference arrays are smoothly increasing. So smooth check, I need to have array passed and size of the array passed. These two are sufficient to find out if the given array is smooth or not. So if it is smooth, then I need to append 1, and that has to be to the answer. So since it is a binary string, let's take s plus equal to 1 if smooth check returns valid. Else if it returns invalid, then s plus equal to 0. I can combine this in a single line using ternary operation, because there is only a single condition and both the lines in these blocks are very similar. So I can have this done using ternary operation. And this has to move out of this block. I do not need this if else. One indent back. Now I need to fill in this smooth check function. Smooth check function will take the array and the size of the array and return boolean. So boolean, I need to have it as a static function as well. Smooth check int array, it takes an array and size of the array, and it does smooth checking operation. Now what do I mean by smooth checking operation? I need to check if it is strictly increasing, and I need to get the difference array. So let's take the difference array. What will be the difference array size? For n elements, there will be n minus 1 differences. So n minus 1 size for int I equal to 0, I less than n, I plus plus. How will I get the difference? The current difference is array of I plus 1 minus array of I. But then if I'm doing this, I plus 1 will fail for I equal to n minus 1. So I need to stop at n minus 2 itself. So int current difference, what should I compare this current difference with? I need to check if the current difference is strictly greater than the previous difference. Do I have previous difference? No. So let's take the previous difference. Previous difference is going to be by default. I do not have any differences as of now. So I'll take it as integer dot min value, because any difference that comes in, that can be greater than this min value difference. So int current, I need to check if previous difference is greater than, sorry, is less than current difference. If it is greater than or equal to the current difference, sorry, if previous difference is greater than or equal to the current difference, then can this be increasing in nature? Previous is greater than equal to current, it is going to be in decreasing nature, so I'll return false. Now additionally, I also need to check if the array is strictly increasing, that is if array of I plus 1 is greater than array of I. That is, if array of I is less than equal to array of if array of I plus 1 is less than equal to array of I, then it is not strictly increasing, it is decreasing fashion. So then that is the next element is less than the current element. Then as well, I cannot be continuing any further, I'm going to return directly. Now whatever is the current difference, that has to go into my difference array, right? Because that is what is going to go into my smooth check next. So again, for this I need some k plus plus equal to current difference. Let's take that k over here itself, k plus plus. And finally, can I directly return true? No. When can I return true? Only when the current difference array is also smoothly increasing. So I am going to use the smooth check function by passing in difference array, and size of the difference array is n minus 1, and check if it is smoothly increasing. If this is smoothly increasing, then I can finally return true. Or there is also one more case where I can return true when there is only one element. So when there is only one element, my array is smoothly increasing. Or when the current array is strictly increasing and also the difference array is smoothly increasing, then I can return true. So with this, yeah, finally I need to be printing system out println s. Let's quickly run this and check. Okay, this is going to be n minus 1. Okay, I did it outside the block. All the outputs are matched. Let's quickly submit it. Now if you see, we did not handle that less than 30 case, right? Let's see if it passes firstly. It gave us time limit exceeded, obviously because of our uh, time complexity exceeding the limit. So how can I avoid that? Well, I can avoid that from happening by checking if n is greater than equal to 31. That is, it is greater than 30, because I know that I will get only 10 power 9 as the maximum element for 30 elements. Greater than 30 elements, it definitely has to be something more than 10 power 9. So if n is greater than 30, then no matter how many elements I remove, I still will not get I still will not get an increasing array, sorry, smoothly increasing array. So no matter what element I remove, I cannot get a smoothly increasing array. So I can simply print 0 for all those times along with Okay, we are already having S, right? So let's just shrink it to that. You can also do S plus equal to 0. It will take care of typecasting to string. Println of S and continue to the next test case. Let's see if this works. Worked. Wrong answer. Why do you think so? Well, if there are 31 elements, then you can remove one element and then make it valid, right? Because we know that if there are 30 elements, then it is valid. Then if there are 31 elements, obviously I'm going to remove one element each time. So still there is a chance that it can be valid. So I need to check if it is greater than 31. It is greater than 31. Let's see. Correct answer. Understood. So if I had even 31 elements, then when I remove one element, it becomes 30 elements. And I know that 10 power 9 can be the maximum element if n is equal to 30. So even if it is 31, here he has given us a task of removing one element, right? So I'm still going to check after removing that one element, is my array smoothly increasing? If it is still not smoothly increasing, then obviously I'm going to print for what elements it is not smoothly increasing, for what elements it is smoothly increasing.
Thank you for sticking until the end, guys. Hope you liked the video. If you found the video helpful, share it to your friends and make sure you upsolve all the 4 problems. And if you are having any queries, drop them in the comment section. Make sure to like, share and subscribe to Smart Interviews for more such videos. Thank you. Arun signing off.